Welcome, listeners, to another episode of Green Machine's AI for a Sustainable Future. I'm Mark, and as always, I'm joined by the man who can spot deforestation from space, but still can't find his car keys. Tom.
Thanks, Mark. I'll have you know I've upgraded to a smart key finder. Now I can lose that too.
Well, folks, today we're zooming out AI way out AE to talk about satellite imagery analysis. It's like Google Earth on steroids, with a PhD in environmental science. So, Tom, remember when we thought high resolution meant our old Nokia phone cameras? Well, satellite imagery has come a long way since then. We're talking about AI algorithms that can spot a tree hugger from space.
Absolutely, Mark. It's like having a tireless, all-seeing environmental detective circling the globe 24/7. These AI-powered satellites are giving us unprecedented insights into our planet's health, from tracking deforestation to monitoring urban sprawl.
You know, it reminds me of that time I tried to use a drone to find the best surf spots. Turns out a global network of AI-enhanced satellites is slightly more effective for environmental monitoring.
Slightly, Mark? It's like comparing your surfboard to the Starship Enterprise. These systems can detect changes in land use, measure sea ice thickness, and even predict natural disasters before they happen.
But Tom, isn't there a concern about privacy? I mean, what if these satellites catch me sunbathing in my backyard? Now that we've established I won't be caught on satellite sunbathing, let's dive into how AI actually makes sense of all this data. It's not just about pretty pictures, right, Tom?
Right you are, Mark. AI, particularly deep learning models, is the secret sauce here. These algorithms can process vast amounts of imagery and extract meaningful information in ways that would make your head spin faster than a satellite in low Earth orbit.
So it's like having millions of interns scanning photos, but instead of getting coffee stains on everything, they're identifying complex patterns and changes over time?
Exactly. And these AI interns never sleep. They can detect illegal logging, track the spread of diseases in forests, and even measure the energy efficiency of buildings across entire cities.
Wow, that's impressive. But I have to ask, can they tell if I've been watering my lawn during a hosepipe ban? Let's take a deep dive into how satellite imagery analysis is helping our oceans. And no, Tom, I don't mean literally diving from a satellite.
Thank goodness for that, Mark. I left my spacesuit at the dry cleaners. But you're right, the applications for marine environments are fascinating. AI algorithms can process multispectral satellite data to track phytoplankton blooms, measure sea surface temperatures, and even detect illegal fishing activities.
So it's like having a virtual marine biologist constantly patrolling the seas? That's got to be a game changer for conservation efforts.
Absolutely. It's providing crucial information for understanding marine ecosystem dynamics, managing fisheries sustainably, and protecting vulnerable marine species. Imagine being able to track a pod of whales or monitor coral reef health from space.
That's incredible. But I have to ask, with all this powerful technology, are we at risk of information overload? How do we make sure we're not drowning in data? You know, Tom, all this talk about satellite imagery analysis reminds me of a Wardley map. Shall we plot this out?
Absolutely, Mark. Let's start with the user needs at the top of our map. We've got environmental monitoring agencies, climate scientists, and even urban planners relying on this technology.
Right, and moving down, we've got the satellite imagery itself as a key component. That's pretty evolved and standardized by now, wouldn't you say?
Definitely. But the AI algorithms for analysis are still rapidly evolving. They're moving from custom-built to more standardized solutions, but there's still a lot of innovation happening there.
Interesting. And what about emerging technologies like those small satellite constellations and hyperspectral imagery we mentioned earlier?
Good point, Mark. Those would be on the left side of our map, in the Genesis and custom-built stages. They're set to shake things up in the near future.
So looking at this map, it seems like the real strategic focus should be on developing those advanced AI capabilities while also preparing for these emerging technologies. It's like trying to surf the perfect wave while also building a better surfboard.
That's a surprisingly apt analogy, Mark. And don't forget the challenges we discussed, like ensuring AI interpretability and managing increasing data complexity. Those are like the rocks and currents we need to navigate.
Right you are, Tom. So the key takeaway from our Wardley map is that organizations need to balance current capabilities with future technologies, all while addressing interpretability and real-time processing needs. It's a complex landscape, but one with enormous potential for environmental monitoring and protection. Well, folks, we've orbited around the fascinating world of satellite imagery analysis, from AI-powered environmental monitoring to ocean insights. Remember, the next time you look up at the sky, there might be a satellite looking right back at you. Hopefully not while you're sunbathing.
Indeed, Mark. We've seen how this technology is giving us a truly global perspective on environmental challenges, allowing us to respond faster and more effectively than ever before. It's not just about observing our planet. It's about gaining the insights we need to protect and restore it.
Absolutely, Tom. And on that note, we encourage our listeners to keep their eyes on the skies and on the latest developments in AI and satellite technology. Until next time, this is Mark and Tom, signing off from Green Machines, AI for a Sustainable Future. Remember, in the race to save our planet, every pixel counts.